In this section, we're going to start making things more real now, and we're going to start bringing the REST, or representational state transfer fundamentals, into the picture on top of the HTTP things we've already discussed. So REST is an architectural style that has very broad reach. It emphasizes features such as scalability, generality, independent deployment, reduced latency via caching, security, and encapsulating legacy systems. Many services balance a truly RESTful API with a positive developer experience. So in other words, most APIs are not truly or fully RESTful. They are RESTful-ish, and we try to balance that with a positive developer experience. When you're thinking about REST, you define your service's resources and are typically as a collection of items, like users. And that would be a collection of users. And then you put a Jeff user in there, or a Aiden user in there, or a Grant user in there, and those would be the items within the collection. These resources are state, so think in terms of nouns, right? These are things like a user is a noun. Do not think in terms of behavior. With REST, the general behaviors are create, update, get, and delete. Your standard CRUD operations, create, read, update, and delete, are your typical behaviors that you put on top of these resources. And determine your hierarchical URL paths to expose your resources. So spending time on what your URL looks like to expose these resources is a critical thing that you really should be investing a lot of time in. Partially because URLs to resources identify that resource. It's a way to get to it. It's a locator. And the URL should be stable over time. That is, a customer might use our URL to create a resource today, and then 100 years from now, that URL should be usable in order to go and read that resource back. So the URLs are typically stable over long periods of time. And it's important to consider that. So let's take a look at an example. So to do the standard CRUD-like operations, you might create a REST path that looks something like this. So after the HTTP scheme, : / and then the host name, then we have a slash and the rest of the URL path. So we might have something like /song management. Song management is the name of a document that contains the resources. Sometimes this is omitted and the actual host name, that is the name of the service, represents the document itself. After the document, if you have it, is then typically a collection name. So this service is exposing a bunch of users. Users is a collection resource. It holds a bunch of items. Of course, those would be the individual users. When you are naming this collection, we suggest you use plural, so it's users plural, for example. URLs, we recommend lowercase for almost all things. And again, it should be a noun, right? Users is a noun. We also recommend that within your URL, you avoid having more than 2 collections. That makes the URL long, harder for people to follow. In this URL, we have 2 collections. There's users, and then you would have an ID of a particular user, and then that user might have multiple playlist collections under that. Or it's a playlists collection, and then within the playlist, there might be playlist IDs for each of the individual playlists that a user might have. So users and playlists are 2 collections, and they're in a hierarchy. So you go to the users collection to talk about a specific user identified by an ID. Then for that user, the playlist collection, and then under that, a playlist ID to indicate a particular playlist for that particular user. So now we have the item resources, which have IDs to represent them, and you'll use, request and response body will hold the item state here. To create a user, you would typically use patch, RFC 5789, with a JSON merge patch request body. And this will go and create the user of the ID that the client specifies on the service. And then the JSON merge patch is the JSON that indicates all the properties that you are setting for that user. Patch is used to do a create. It's also used to do an update. So let's say you create the user and you need to update their phone number or their email address. So then you would also use patch. So patch is useful for create and it's useful for update. Patch also works very well in versioning scenarios, which I'll be talking more about very shortly. If you want to offer create and a wholesale replacement, that is, you want to replace the entity or the resource in its entirety, then you can use put with a JSON payload. But you have to be aware of versioning issues here. Let me briefly explain. So let's say that in version 1 of your service, you have the person's name and their phone number. And so a client who knows about version 1 of the service will only ever go and set the name and the phone number. Let's say in version 2 of the service, you now add an email address as a new property on the resource. Well, if the V1 client does a put operation, it doesn't know about the email address. And so if the email address was set by a V2 client, the V1 client, when it does a put, it will erase what was there. It'll erase the email address. And that causes state to vanish. Patch, as you'll see momentarily, because I have an animated slide that I'll walk through, patch solves this versioning issue. So it's highly recommended you use patch whenever possible, even over put. Read operations would be done with a get, and then of course it'll return a JSON representation of the resource in the body, response body. And then delete, you would of course use delete. And as I said earlier in the course, all these operations must be implemented idempotently on the service. All right, so now let's walk through this animated slide so you can see all these pieces fitting together. In the top left-hand corner, I show a database, if you will, or a table, and these are the resources on the service. And the service has defined that each resource has several fields on it, like an airport code in this example, a creation date when the resource was created, the number of runways that this airport has, and the number of takeoffs per hour that this airport is experiencing. Then for each of those fields, we have the data type. You'll notice I'm using very clear contracts here, that the airport code is a string, the creation date is also a string, but it would probably be an RFC 3339 format. There's runways, which is some kind of number, and then there's takeoffs per hour, which is also a number. Now I could say integer here if I want to, but number means it could be integer or floating point. And while these would only be integer values in real life, a lot of languages only support floating point numbers like JavaScript. So I'm just saying here it's a number, and that means it'll map to multiple languages better. Then I indicate for each of these fields what it is set by. So the airport code is set by the client. The creation date is actually set by the service when the resource is created on the service. And the number of runways and takeoffs per hour, these are values that are set by the client. Then I have a mutable indicate once the resource is created, can this field be mutated or not? So the airport code cannot be mutated because it is the key, it is the ID of the resource itself. The creation date can't be mutated. Once the resource is created and we record the date, that never changes over the lifetime of the resource. Then we have the number of runways, because over time an airport can increase or decrease the number of runways it has. And of course, the number of takeoffs per hour at any given airport is very dynamic. And then I show, I do have an asterisk here to call out that it's recommended that you minimize the amount of immutable fields so that customers don't have to delete and create. So if you had some other immutable fields here, probably not creation date, but something else that you marked as immutable, if the customer wants to change it because you marked as immutable, they can't. But what they can do is they can delete the resource and create a new one, and that gives them the ability to change it. Well, if that's okay for your service, then you might as well just let the resource or the field be mutable in the first place. So try to minimize the use of immutable fields. All right, so I already have a resource that's inside this table, this collection, if you will. SEA is the airport code for Seattle Airport. And let's say it was created on September 1st of 2020. It has 3 runways, and the number of takeoffs per hour is about 810. Now let's say that a client wants to go and add another resource to this collection. So to create the resource, here we're going to create LAX, which is the Los Angeles Airport. I'm going to do a patch operation from the client to the airport's collection to create a entry whose key or identifier is LAX. And in the payload here, I'm specifying that the number of runways field is set to 4. When I execute this, over here in the table, for resource number 2, it adds LAX, it adds the creation date and time, it adds the number of runways, in this case 4, and the takeoffs per hour is left blank because I didn't actually set that here. Now let's say we want to go and update this resource in the service. Well, update can also be done with patch. So I'm going to patch to the same path that I had before, airport/LAX. And because this is a JSON merge patch payload, I'm saying here that I want to update the takeoffs per hour field to be 1500, and I don't want to change any other field. So that's just going to update this one field here for the LAX resource to 1500. All right, now let's say the client wants to go and read the current state of the resource. So it can do a get operation to airport LAX, and that's in the request, and the response will come back with the code, the creation date, the runways as 4, and the takeoffs per hour as 1500. That comes back in the response. Now let's say we want to list all the airports that are in the service. To do that, the client would issue a get to the /airports collection, right? So now we're not getting an individual item in a collection, we're doing a get to the whole collection itself, airports. And our recommendation here is that this return a JSON object that has a value property in it, which is an array of all the elements that are coming back. So you can see there's one element in the array where the code is SEA, and then the other fields, which I don't show here because I have limited slide space. And then another element in the array where the code is LAX and its value, and then any additional, if there happen to be more in the collection, you would see below. And then for collections, I'll talk more about these later in the course, but collections can grow to very large size. And doing a get that returns a whole collection that might have literally billions of items in it is too costly for a service to be spending all its time doing. So a lot of times services will return a page or a subset of a collection back. So only, let's say, maybe 1,000 elements. And then it will also include a next link field in the response payload with some opaque URL here. The client code would then walk the value of arrays to process them all, and then it would do a get operation on this opaque URL, and the service would return the next subset from the collection, and then the client would process those. They would have a new next link, it would do another get, and so on and so forth, until the service didn't return a next link in the response, and then the client would know that it's done, that is it's processed everything in the collection. And now finally here, let's say the client would like to delete the LAX airport from the collection. So it would do an HTTP delete method on the airports collection for LAX, and that of course will go and remove the LAX entry entirely from the service resource. So now that you get a good sense of how you can do pretty much everything you want to do with patch, get, delete, right? Really just those three is all you need in order to be super successful. Now let's talk about the API design checklist. So when you're designing this API, you want to focus very heavily on great and consistent naming. The terminology you use is really important, and that you use that terminology consistently throughout your entire service. This can help a lot with customers understanding what your service does and how it works. Next, ensure that the resource path makes sense. In my example there, I had airports, which you'll notice was plural because it was a collection, and then you had the code for the airport underneath it. I think it's very clear as to what that means. And then it was the same path being used for the patches and the gets and the deletes. Simplify a call with few required parameters in JSON fields. That is, you wanted the customer to be able to be successful with your API, doing the minimum amount of work necessary. So keep the path simple. Don't require query parameters if you can avoid it. Require only the minimal set of properties in the JSON payload that's being sent, if you can get away with it. Have clear contracts for any string values that you pass back and forth across the wire. I've said this numerous times now. Use proper response codes and payloads so the customer can self-diagnose a problem and fix it on their own so that they don't have to get customer support involved. This is really critical. Customers write code, for some reason it doesn't work. They would like to be able to fix it themselves and be back up and running in 5 minutes maybe. It's a terrible experience where they just can't figure out what's wrong, have to contact customer support, maybe wait a day or two for customer support to reply back. Meanwhile, they're on to other things, they've lost their focus, and this is all adding up to a negative experience with your service. You really don't want that. So we focus very heavily on allowing customers to self-diagnose problems and try to fix them on their own. Whether you should have one big resource or have multiple little resources. Like some people might say to put after LAX / takeoffs per hour and have that be part of the path. That's fine. That means that you can update the takeoffs an hour. But let's say you wanted to change the number of runways and the number of takeoffs per hour. Well, now you wouldn't be able to do that with one IO request. But the way I showed on the previous slide with patch, you actually could update those two fields with one IO request. So I recommend having one big resource that's identified by the URL, and that allows you to do multiple updates with one IO, and that means that the customer code will be faster. Also, each HTTP request should be atomic, so that allows me to change the takeoffs per hour and the number of runways in a single atomic transaction, as opposed to making two separate requests to do them. Then it cannot be done atomically. The service should fail the creation of a resource if some of the required fields are missing. However, we don't want to allow resources to be created that are in a partially good state. It's very hard to reason about them and to work with them. So the construction or creation of a resource should have everything required in order to make that resource usable. Note, and I've said this before in the course too, you can always add APIs later. So keep things really simple now. Do the bare minimum in order to address your hero scenarios that customers need. You can always add later, but once you've added something, it's very hard to take it away. Also, if you're trying to make things more convenient, sometimes that can be done in the client libraries or SDKs and doesn't have to be done by the REST API of the service itself. So that's another place where you can simplify things on the client without having to change the service. So the service is simple, and the client that wraps it can have more complexity to it. Various things that are worth considering. And then, of course, write code that really uses your API. Don't just design the API and assume it's going to be good. Write code, test it, debug it, try to run up against the issues that a customer would have. Of course, let them preview it and give you feedback on it, and then iterate to make it perfect.